Okay, so we're 2-4 day 2, yep. Okay, so San Luis, California is 12 miles due north of Grover Beach. Okay, so San Luis is 12 miles north of Grover Beach.
We can't see what you're writing.
Okay, Aurora Grande is 4.6 miles east of Grover Beach. So Aurora Grande is 4.6 miles east of Grover Beach. What is the bearing of San Luis from Aurora Grande? So I need to draw a picture of this, yes? So the easiest thing to do is start with a big north-south line. You have to have the end up here so we all know they're a north-south line. Okay. Yes. Okay, so we have something that's due east. So Grover Beach is our like consistent thing, right? Mm-hmm. Okay. So I don't always do this. Sometimes I'll just do a bar like that. It just kind of depends. Their picture that they have given you has Grover Beach here. And so due north is San Luis. Actually. And due east is Aurora Grande. So it says due, correct? So what does that mean this angle is right here?
Straight.
That's
Right angle.
Thank you. So if this is a right angle, I can make a what? A right triangle. Now it wants the bearing of San Luis from Aurora Grande. So where do I start? Which one do I start at? From Aurora Grande, and I'm going to where? San Luis. So what angle is that I want then? That one right here, correct? But bearings don't go, actually, I should have made it. Bearings go from the north-south line, yes? That's what your definition said? Yes. So I probably should put it right here. So we have a right triangle. That was horrible. We have a right triangle with all this information here, don't we? But the actual angle that we need is where? This one, isn't it? For a bearing. Look at your pictures from your bearings from your notes. Where does the angle touch? Doesn't touch the x-axis, it touches the what?
Y.
The y. So I actually need this purple angle. But if I find the blue angle, can I find the purple angle? Yes. So my bearing is northwest, correct? So it's north and west. We need to find the angle.
Mm-hmm.
So how are we going to do that? Tangent.
Yeah.
And the inverse tangent, correct?
Mm-hmm.
So the inverse tangent of 12 over 4.6, that gives me the inside angle. That's not what I want, is it? How am I going to find the other one? So it's actually going to be 90 minus the inverse tangent of 12 over 4.6. And I want it in your calculator all at one time. I do not want it in pieces. I get approximately 20.97. So approximately 21 degrees. So my bearing from Aurora Grande to San Luis is north 21 degrees west. Does that make sense?
Yeah, how did you know to write it on the west side and not the other north side?
Oh. Well, if you're going to end here, typically I probably would have just done this. Like drawn this if I was doing it myself, because it said north and then it said east. Oops. Does that make sense?
Yeah.
I wouldn't have put it in a coordinate plane. But, and then when I did that, then I would just draw my new north-south line here. So then I would be looking for this angle. If I were to draw that all the way down. Sometimes their pictures, they know what they want it to look like. And so it seems like they sometimes have a picture before. And I will tell you, a lot of times I read something completely through before I even try. And I write things like this. I know this and I know this. So what am I going to do with that? Did I make it?
Yeah.
Okay. A boat is traveling on a course of a bearing of north 52 degrees, 40 minutes east. Okay, so it probably should give me a north-south line, right? So it's traveling north 52 degrees, 40 minutes east. So which direction is that? Up or down? Up, left or right? Right. So this way? And so this angle right here, so I need that into a decimal to work with it. So it'd be 40 divided by 60, so that would be 2 over 3, so 2/3 is 0.66. Guys, degrees to minutes, you divide, yes? So 40 divided by 60 would reduce down to 2 over 3. And that would be 0.66? Okay, so 52.66 degrees. Okay? For a distance of 238 miles. So this is 238. How many miles north and how many miles east has the boat traveled? Well, this is the north one, yes. And this is the east. And I don't want E and but. Is that north and is that east? Yes. So can we just call them X and Y?
Yeah.
Do you see how that picture came about?
Yep.
So which one do you want to find first?
X.
X? Okay. So how am I going to find X? Sine, cosine, or tangent? Nope. Cosine. Because I have the hypotenuse, yes? And I need the adjacent. So the cosine, I'm going to write cosine of theta because I don't want to keep writing that every time, equals X over 238. So X is going to equal 238 times the cosine of 52.66. And I'll do that a lot, guys. I'll write, if I'm going to have to manipulate an equation a whole bunch, I'll just write theta. Don't worry about it. Wait. Don't touch your calculator till you're done with your problem. Are you done with the problem yet? Nope. What do we got to find now? Y. So how am I going to find Y? Sine. So sine of theta equals Y over 238. So y equals 238 sine of 52.66. I expect, guys, on your homework and on your test, this is the most important thing to me. I could really care less about what it approximately is. I want to know, do you know the math to get there? Because your calculator can do it. I know that. Okay, now if you put those in your calculator. You should get approximately 144 miles north and 189 miles east. Did you get that? So, just because these have more words in them, did the problems get any harder? No. They're about to, though. Just because it's fun that way.
It's fun for you to watch us struggle.
Productive struggle is so amazing. It makes you a stronger person. Okay, so this one will probably always give you a picture. So I'm going to give you the picture, so we're going to draw the picture. Don't worry about the words. Okay, so let's analyze the picture so we can actually draw it. You see the flagpole? Okay, do you see the right triangle off of the flagpole here? And then one from the base? Okay, so the easiest way to honestly do this is draw the flat one first. Kind of at an angle. Okay, then I draw my flagpole up. And sometimes I've got my erasable pen, so sometimes I'll dig out 2 different colors if I need to. If my brain's not going for it that day. And then just down to my corner. So I've got X, C, H, D, flag. Right angle here. Right angle here. And this angle right here is 61.7.
What's your other one?
54.5. Is it important for you to draw a big enough picture that you can write on it?
Yes.
Yes. Okay, so in the this is the whole statement. It says, Figure 10 is a diagram that shows how Diane estimates the height of the flagpole. She cannot measure the distance between herself and the fence, herself and the flag, because there's a fence. Did you notice the fence?
Yes.
Okay, you can't get a tape measure through that fence? Come on.
You can't jump over that fence.
Yeah, they could have at least made it like a privacy fence, right? Okay, anyway, there's a fence blocking her way. She can't get there. So she stands at point A, facing the pole, and finds the angle of elevation of A to the top of the pole to be 61.7. So from A, angle of elevation, so this is flat on the ground right here, right? Up is 61.7. Then she turns 90 degrees and walks 25 feet. from point B, and she measures the angle between her path and the base of the pole to be 54.5. So here's her path, the base of the pole. Okay? So now she wants to find the height. So you have two right triangles, yes? You ultimately want to get this. Right now, that is in this triangle that's in the air, correct? And you have an angle and you have a height. So you need another side of the triangle, correct? So you probably need a side that is in the other triangle. So what side is also in the other triangle? X. So if I find X, can I find H?
Yes.
Yes. Now I do not want approximation on X. We are using exact values to use on H. Got it? I know if you look in the book, it gives you the approximation and then they use it, and I'm not up for that. We have a calculator that will do so much more. Let's utilize it. So how am I going to find X? Actually, let's make a plan. Let's work backwards because I keep telling you make a plan, yes? So if I knew X, how would I find H? I use tangent. It would be tangent of 61.7 equals H over X. So then H is going to equal X tangent of 61.7. So that's my plan, right? So now I need to go find what? X. So how am I going to find X? Now you got to kind of erase all this extra stuff right here, right? So you're just looking at the bottom.
Why don't you use tangent?
So tangent of 54.5 is equal to X over 25. So X equals 25 tangent of 54.5. I'm writing lopsided. So all I have to do is take this and do what with it? Put it right there. So H, let's write our equation. What is H? What's the equation we're writing?
25 tangent of 54.5 times tangent of 61.7.
Pretty sure you get approximately 65.1 feet.
I'd probably just look at the flagpole and be like, yep, that's about 20 feet tall.
And yeah, you'd be wrong.
Probably, but a lot more simple than that.
Okay, so on that one, we drew the picture, read it, labeled. Well, drew the picture, labeled, read it all through, right? Anything you have a complicated picture, draw the picture first, then go. Okay, so the next one, we're going to have a complicated picture again. I'm going to show you what it looks like. We're not going to even read the problem. We're going to focus on just making the picture. Ooh. See it?
Yep.
And we're going to focus on making that picture simple. There's a lot of stuff going there.
No, I want to make that helicopter in detail this one.
Yeah. Okay. So they turned their nose south line sideways, didn't they?
Yes.
Okay. So give yourself that. Try to make that basic. Try to draw that picture. A lot of times I even turn it over, but. Do not put C exactly halfway between A and B. You are doing yourself a disservice big time if you do that. Right, but people they decide to put them right, yeah. It never works out good. Because then they cut that base exactly in half. Because you'll have to draw this picture by yourself also. So. And you guys have a luxury. You can change your paper around, yes? Swivel it.
Where it says 25, what is that talking about there?
It says 25 minus x.
Okay.
This is just, this little C to D is the vertical distance from, how high the helicopter is.
No, the helicopter? Yeah, go for it. No, the CZ.
We'll have to see. Sometimes I typically do not draw it on there till I know I need it. Okay, we good with the picture?
Yes.
Okay, so now, this is what my picture looks like. Similar to yours, maybe. Okay, so it says the helicopter is hovering over the desert when it develops mechanical problems and is forced to land. So do we need to know that it's up here? No. It's landing right where?
Yeah.
Right there. Okay, when it's forced to land. After landing, the pilot radios his position to a pair of radar stations located 25 miles apart. So that would be A and B. Do you now know why this one says X and this one says 25 minus X? Okay, because this whole distance, the reason why I said do not draw this, even though it says it's not, because Savannah's like, well, it says 19 and 13. It can't be. You're right. But guess where people put it? Right in the middle, and then they make it an isosceles triangle and cut this exactly in half. Is that right? No. Even if you think it is, you can't until you can prove it. On a straight road running north-south. That's why it's on a north-south line. The bearing of the helicopter from one station is north, east. So that would be in this one, right? Because this one would be what way? South, east. From here. Get that? Because it goes down. Okay, so this is 13. From the other one is southeast, 19. After doing a few trigonometric calculations, one of the stations instructs the pilot to walk due east 3.5 miles. So, due east would be, well, due east is first wrong, but 3.5 miles to the road. Is this information correct? So he is saying this right here is what? 3.5 miles. Well, first of all, it'd be due west, wouldn't it?
Yeah.
Yes? Everyone following?
Yeah.
So he's wrong, it'd be due west. But is it 3.5 miles? That is the question. We don't know. So I need to figure it out. Well, if I look at this right here, Well, I have x and I have y, correct? And if I look here, I have 25 minus x and I have y. Well, I don't have 2 of anything, but I have x and y in both of them. So can I set up a system of equations?
Yes.
Yes. So let's talk about this triangle right here. So I have x and y and 13. What function do I have? Tangent. So tangent of 13 degrees is y over x. Okay, what about the other triangle? Tangent again of 19 equals y over 25 minus x.
Yes.
Okay, so we ultimately want to know what y is, correct? So if we did equations like this before, 2 equations, 2 variables. If I want to know what y is, if I solve both of these for x, can I set them equal to each other and find y? If they both equal x?
Yes.
Yes? Okay. Then some people would say, well, y would be easier. It would be. Could I solve it for y and then plug it back in? And you'd find your x and then plug it back in? Yes. So which one do you want to do?
Find the x.
Solve for x, then set them equal to each other, and then find the y?
Yeah.
Okay, so if I'm solving this for x, I would multiply it by x, but divide by tangent, just like we've done. So this would be x equals y over the tangent of 13. And this one's going to follow the same, well, kind of. This one would be 25 minus x equals y divided by the tangent of 19, but I still don't have x by itself, do I?
No.
Well, I'd have to add x and subtract this. So x, oops. So 25 minus y over tangent of 19 equals x. Now, none of it is pretty, correct? This is like not pretty to me. How about you? No. But did we do the math that we know, and we're just going to have to deal with it, right? So that since this equals x and this equals x, they are now equal to what? Each other. Now, I think probably over here we should get common denominators before we do anything. Don't you?
Yeah.
So the common denominator is going to be tangent of 19. And so this would just be 25 tangent of 19. Everyone following? So I have y over tangent of 13. I'm going to keep working on it. Equals 25 tangent of 19 minus y over tangent of 19. So when I have a fraction equal a fraction, how do I solve it? Cross multiply?
Uh-huh.
So that would be y tangent of 19 equals, now when I cross multiply by this, I have to distribute, don't I?
Yes.
So that would give me 25 tangent of 19 times tangent of 13 minus y tangent of 13. I know I'm going kind of fast, but just doing that basic math, not thinking too much about it. So what am I solving for? Y. So I got to get the y's on the same side, yes?
Yeah.
So I have to
Add.
add over this. So I have y tangent of 19 plus y tangent of 13 equals 25 tangent of 19 tangent of 13. Now I have two y's. I have two things with a y in each of them. Can I factor a y out? So I get y tangent of 19 plus tangent of 13 equals all of this stuff again, yes? And then I just divide. So I have y equals 25 tangent of 19 tangent of 13 divided by tangent of 19 plus tangent of 13. So that is going to tell me whether I'm right or wrong. And when I put that all in the calculator, when I put that all in my calculator, I get approximately 3.5 miles. Make sure when you put this in your calculator, though, you put parentheses around the numerator and the denominator. So was he right on the 3.5 miles?
Yes.
Was he right on the due east? No. Okay? So every single problem, you should have a picture drawn and something attempted. Not, and I don't know.